Hello. Welcome back to our free CCNA series or Cisco Certified Network Associate. So this will be our episode 8, and I cannot believe that we already reached this episode. So for today's topic, we're going to discuss about VLAN. So VLAN, it's something that we already have a discussion with, but we're not really going deep dive about these VLAN. So for today's episode, it will be focusing on what VLAN, why are we using it, what are the default VLAN, what are the things that we needed to know in order for us to pass that certification, right? So first, I'd like to start with this. So again, this is something that you can get on Cisco website. Just go with the CCNA topics. So we're getting all those information. We're following the syllabus that is provided by Cisco, and then we're making sure that we're going to check all the lists that Cisco posted there. So let's start with access ports. We have here data and voice. Now, if you're going to, let's go to our packet tracer. I'm opening up our packet tracer just for us to provide a real example on what's the difference between a data and a voice. So if you've been using packet tracer or doing configurations, probably you have an idea what the data VLAN is. So when you configure the switch port access, so that's the default way to have VLAN set on a network interface. And we know that there's two types of configuration on the ports. So the first one would be the access, and the second one would be the trunk port, like this one. And the main difference between the two, you know that the access port by default, you only have single VLAN connected to it. But in trunk port, this is where you can add multiple VLANs to that specific port. So we know that for a trunk port, it's usually connected to a switch going to a router or switch to switch. And if it's an access port, this is usually connected on end devices. So that could be the host, the PC, the computers, or even the servers. Now, with the actual setup, like in a real world setup, you're not going to see you probably, if you've been into a corporate setup, most of the time a single user needs a VoIP phone, like a phone setup. And the problem with that is we cannot assign 2 ports for that single user. So what Cisco decided is, instead of having multiple ports and just do a lot of configuration, but at the end of the day, it's just going to be the same user who's going to use that. So we set up VoIP phone. So for that one, so this is your computer, and that computer will be connected to the VoIP phone, and the VoIP phone, that's where we're going to connect to a certain switch. But that certain switch, that would only be a single Ethernet port, right? So that's the reason, that's why we can configure a data and also a voice traffic or a voice VLAN on a single interface, because you don't like to have this as, let's say this is a specific single user, and he's using a phone and also a computer, that there will be allocation for that user for 2 ports. Right, so we don't like to do that. So that's the main reason why we need to know this, because in a real setup, that single interface, it's either you need to create a VLAN for the data itself, for the browsing, for all the things that you need to access on your computer, but you also need to have a VLAN for the voice. And aside from that, on the voice VLAN, there will be a configuration for the QoS, for making it there will be a configuration priorities, how could we prioritize traffic for voice. That's also another option for voice VLAN. Okay, so now with that being said, let's try to configure this one. Let's say go to the switch and connect this one. So we know that in terms of configuration, okay, enable. So let's say there will be like IP phone connected to the FA01. So configure terminal. So the configuration would be switch port. Okay, interface FA01. Go to the interface first, then switch port access, and then determine the VLAN. Let's say let's create a VLAN 20 for this port. And please take note that if you're going to create a separate VLAN for voice traffic, make sure to make it different from the data VLAN, because you can put them under the same VLAN, but that will not serve the purpose of having like multiple VLAN on a single port for data and a voice VLAN. So make sure that they're not like the same. So switch port voice VLAN 1. Let's say for voice it's 100, and for regular VLAN for data traffic we're using like the 20, 30 for a specific department. And if you're going to exit, show running configuration, so you'll see right away that there's a VLAN for VLAN 20 and also VLAN 120 for our voice traffic. So that's how you configure data and voice traffic, this one. And next on our list, we have the default VLAN. So for the default VLAN, this is like normal range, so 1 to 1005. So the VLAN 1, this is like the native VLAN, that's the default. And that's the reason why we have a native VLAN, because we're telling to untag that specific VLAN. And by default, all of the interfaces will be fall under that specific VLAN, which is like the native. And most of the time, the default native VLAN would be VLAN 1. And 1001 to 1005, it's also a special VLAN that we cannot do a lot of changes. But if you're going to configure like show running, like show VLAN brief, you're going to show VLAN brief, you'll see that these are the VLAN that we've created, the voice traffic and also the voice traffic and also the regular access VLAN. So you can see that 1, 2, 3, 4, and 5, those are the default VLAN, and those serves that serves a special purpose for Cisco. So we're not going to change anything from it, but you can see it on the flash. Like if you're going to check the flash memory, you see that this is like the VLAN database where those default and VLAN configurations are being saved. So those are the default VLAN. Okay. Next, we have the inter VLAN connectivity. So for inter VLAN connectivity, we know by default that if there's like a different VLAN, they will not be able to connect to each other, right? Especially even if they are not on the same network. But our goal with this one, we're going to create two networks that will be two different VLAN. Let's say, because we're trying to implement this part of the syllabus from Cisco, so inter VLAN connectivity or syllabi here. So how can we have interconnectivity between VLAN? So we know by default that if it's on different VLAN, they will not be able to connect. That's also the reason. That's why we have to create a VLAN for, like in a real setup, you need to create a VLAN for different department. Let's say you have IT department, they might be like on a VLAN 20, and for the accounting department, they might be on a VLAN 30. So that's how you design a simple office setup. You will create VLAN for let's say VLAN 20. This will be for IT. Let's say VLAN 30. That's going to be for accounting, or let's say for HR. Okay, so this will be the two VLAN that we'll be creating. And again, main reason why we have to create those two VLANs for those departments is because we mentioned that if it's going to be on the same LAN or in the same VLAN, they would be under on the same broadcast domain, and if they are under on the same broadcast domain, there will be collisions that will happen between those devices. Let's say you have here say they are under on a single switch, and here they are like on the HR, and this one will be under IT. And let's say you did not make any configuration that like we're using the default VLAN or like the native VLAN, so every time that there's like a broadcast message, all of those messages will be sent through this computer to this computer to this computer to this computer, right? So we're trying to prevent unnecessary traffic on our network, and aside from that, that also not good for the security, because if you know how to do like how to bypass like security from this single network to other one, as long as you have connectivity from one PC to another, there's a way for you to get information from this PC. And you just have to learn more about like the Linux, the Kali. There are like free software already on how can you bypass security as long as you have basic connectivity from those or between those devices. So aside from security, aside from we're making sure that optimizing the network traffic, so those are like the best practice that we're trying to implement. So for our case, we're going to create VLAN here, VLAN 20. Let's say VLAN 20 for IT, then VLAN 120 for voice, but still IT. And for this one, we're just going to get a VLAN 30 for HR. But then let's not create more about the voice because we're going to focus on the VLAN itself. Okay, so we need to make sure that there will be connectivity from this one. So our network, let's say net would be 192.168. Just going to create that 20 network, and that 20, and for HR 192.168.30.10. So for the gateway, I always reserve the gateway IP to .1, so that we can set up that gateway usually on the interface of a router. And since we're trying to make sure that there's like connectivity from this VLAN, so that's how we're going to create those connectivity. So I'll be assigning the gateway right away, though we did not configure it yet. 30.1 192.168.20.10 192.168.20.1. So I'm going to ping this one, but of course this one will not work just by looking at the VLAN itself and also by looking at the IP. But for us to have a reference, so I'll ping myself first. So yep, I can ping myself. Then let's try to ping the other VLAN, the other department. So of course this one will not work just by looking at the subnet of the IP, which is something that we've discussed already, and also by assigning different VLAN to each of these interfaces. So let's configure the VLAN FA02, VLAN 30, interface fast Ethernet 02, then switch port access VLAN 30. Okay. So show interface status. Let's see. Okay, so I've assigned the 01 to VLAN 20 and FA02 to VLAN 30. So our goal is to have a connectivity between them. So we need to have a router, and this is usually called as like a router in a stick, wherein we're creating a sub interfaces as a router. Okay, let me like sub interfaces on this router, and that will make the routing for this network and to this one, and also allowing the separation of traffic by using the VLAN. So let's go to the router. So no enable, so config terminal, so interface gig 00. I'll now shut this one first. There we go. And then what I'm going to do is I'm going to create a sub interface. So config terminal, so interface gig 00. You have to put dot and whatever number that you prefer, but for our case, I'm just going to create a sub interface for the VLAN itself. So I'm just going to put that 20 just for proper naming convention. So we have a sub interface on that physical port, and what we're going to do is we're going to create an encapsulation. That one queue, it's like making sure that we can create a VLAN tagging on this interface port. So we're going to add 20, and the gateway that I assigned a while ago would be the .1. So IP address 192.168.20.1.255.255.255.0. Exit and go to other interface again. So interface gig 00. We're going to create sub interface for VLAN 30, and then we're going to add encapsulation again. That one queue, it's for us to create tagging. For that, we know that whenever we create VLAN for the interface, there will always be some sort of tagging that will create on it, and the mechanism used for it would be the .1 queue. That's why we're doing that in the configuration. And IP address 192.168.30.1.255.255.255.0. So this will be a class C network, and we're not going to explain that here, but I hope you already have idea what those are for. So show IP interface brief. So right here we already have 20 and 30, and for you to check if it's already added to the routing, so show IP route connected devices. So you can see that under this network we have the connected, which is a 20 network, and 30 network. So the only thing that we need to do now would be the FA03, which would be the trunking. So this will be part of this one. Okay, so trunk ports. We already discussed what native VLANs are, and 8.1q, it's more on the encapsulation itself. This is what how we configure those tagging to this VLAN. So encapsulation .1q. Okay, so right now we're almost done. So the only thing that we need to do is to make sure that the FA03 will be a trunk port, so that it will allow all the VLANs from 1, 2, or whatever switch port it is. So configuration, it's just almost the same. So switch port mode trunk. Okay, and switch port trunk allowed VLAN 20 and 30. Right. So show running configuration, you can see that it's already trunk port, and we allow the VLAN 20 and 30 for this one. And let's see if this will work already. Okay, so I think it's still loading. Let's try to do simulation. Let's see if we can see the tagging from this one. So it's under VLAN 20, so there should be some sort of tagging at the frames. I'll further check that, but let's see if it's going to work. But for sure there will be some sort of tagging not also used with the packet tracer and how the simulation works here. So okay, so as you can see, we can receive traffic now. So if we're going to do real time do the actual ping. So a while ago we cannot ping the other network because it's on a different VLAN, and also it's on a different network as well. So you can see, so I can ping myself that one. So that's how we configure the inter VLAN connectivity. And yeah, I think we're all done. The native VLAN, something that we've already discussed. And yep, that's how you do it. It's actually faster. It's much more faster than I expected. So that's all for these topics. So we're done with the transports, the encapsulation, and also the native VLAN. We also define what's the difference between access and also data and voice. So yeah, that's pretty much it for our VLAN. And let's see if we're going to have a deeper discussion about this one, but this is what we all need to know based on the topics that we have for Cisco. Okay, so that's actually much faster. I thought we were going to discuss this like maybe around 30 minutes, but I think it's just like roughly around 20 minutes since we've done the configuration. But yeah, again, thank you so much again for watching the video. So see you next week for our CCNA series. Thank you and happy weekend. Goodbye for now.